A white dwarf supernova is like the grand finale in the life of a very special type of star. To understand what happens, let's first break down what a white dwarf is, what a supernova is, and then put them together to see how they create one of the most powerful explosions in the universe. What is a white dwarf? Imagine a star, just like our sun, living out its life. Stars are massive balls of gas, mostly made of hydrogen and helium, and they burn for millions or even billions of years. But stars don't live forever. When a star like the sun uses up all its fuel, it no longer has the energy to keep shining brightly. So, it starts to shrink and collapse in on itself, forming something called a white dwarf. A white dwarf is incredibly small compared to how the star began. If you think of the sun as a giant beach ball, then a white dwarf would be more like the size of Earth. Despite its small size, a white dwarf is still incredibly heavy. It's made up of tightly packed gas, making it super dense. A single teaspoon of white dwarf material could weigh as much as a car. White dwarfs are the remains of stars that aren't massive enough to go out with a bang on their own. But if conditions are right, they can explode in one of the most spectacular events in space, a white dwarf supernova. What is a supernova? Now, a supernova is a giant explosion that occurs when certain stars reach the end of their life. There are different types of supernovae, but the one involving a white dwarf is known as a type Ia supernova. This kind of supernova happens when a white dwarf has a very special encounter with another star nearby. Think of a supernova as a fireworks display, but instead of being just colorful, it's mind-blowingly powerful. Supernovae can shine as brightly as an entire galaxy for a short time, and they release a tremendous amount of energy. In fact, they are so powerful that the explosion can be seen from millions of light years away. How does a white dwarf supernova happen? For a white dwarf to explode as a supernova, it needs a companion. This companion is usually another star, and the white dwarf starts to pull material from this neighboring star onto itself. The process is like the white dwarf being a vacuum cleaner, sucking in gas from its companion. As the white dwarf gains more and more material, it gets heavier and heavier. But here's the thing, there's a limit to how much weight a white dwarf can handle. That limit is called the Chandrasekhar limit, which is about 1.4 times the mass of our Sun. If the white dwarf's mass goes over this limit, things start to go very wrong, very quickly. The white dwarf becomes unstable. The intense pressure and heat inside the white dwarf cause nuclear reactions to happen, but these are no ordinary reactions, they're runaway nuclear reactions. In other words, the reactions start happening so fast and with so much energy that the white dwarf can't contain it. The whole star blows up in a massive explosion, a white dwarf supernova. The explosive event when the white dwarf explodes, it doesn't just puff out a little gas or dust. This explosion is catastrophic. All the material inside the white dwarf gets blasted outward into space at incredibly high speeds, up to 5,000 kilometers per second. That's faster than a rocket ship. This explosion is so powerful that for a short time, the supernova can outshine its entire galaxy. Imagine a single star being brighter than billions of other stars combined. That's the kind of energy we're talking about. The light from a white dwarf supernova can travel across the universe, allowing astronomers on Earth to observe it even if the event happened millions of years ago. Some of the most famous supernovae have been spotted from Earth by both telescopes and sometimes even the naked eye. What happens after the explosion? After the explosion, the white dwarf is completely destroyed. There's no trace of the original star left, it's gone. What's left behind is an expanding cloud of gas and dust, which we call a supernova remnant. This cloud can spread out over millions of miles, eventually blending into the space around it. But even though the white dwarf is gone, the explosion itself has a lasting impact on the universe. You see, during the supernova, elements like carbon, oxygen, and iron are created and spread throughout space. These are the same elements that make up planets, and even us. In fact, the iron in your blood and the calcium in your bones likely came from a supernova explosion billions of years ago. So, in a way, we're all made from stardust. Why are white dwarf supernovae important? White dwarf supernovae are incredibly important to scientists for a few reasons. Standard candles. These supernovae always explode with the same amount of energy and brightness. This consistency makes them very useful as standard candles for measuring distances in space. By comparing how bright a supernova appears to us with how bright we know it actually is, astronomers can calculate how far away it is. This helps scientists understand how big the universe is and how fast it's expanding. Creating heavy elements. As mentioned before, white dwarf supernovae produce heavy elements like iron. These elements are crucial for forming new stars, planets, and even life. Without these explosions, the universe would be a much less interesting place. Studying dark energy. By using white dwarf supernovae to measure the distances to galaxies, scientists have discovered that the universe is not just expanding, but it's expanding faster and faster. This discovery led to the idea of dark energy, a mysterious force that's causing the acceleration. So, white dwarf supernovae have played a big role in helping us understand this strange and puzzling force. What would happen if a white dwarf supernova happened nearby? Supernovae are rare, but when they do happen, they're usually far, far away. If a white dwarf supernova occurred nearby in our galaxy, it would be an incredible sight to see. The explosion would be so bright that it might even be visible during the daytime. But we wouldn't need to worry about it harming us. Even though a supernova releases a lot of energy, most of the dangerous radiation and particles don't travel far enough to affect Earth unless the supernova is extremely close, within about 50 light years. Thankfully, there aren't any white dwarfs close enough to us to pose a threat. The life cycle of stars. To put the white dwarf supernova into perspective, it's helpful to think about the life cycle of stars. Stars are born in clouds of gas and dust, where they grow by gathering more material. Once they become massive enough, they shine brightly for millions to billions of years. Eventually, stars like the Sun run out of fuel and shrink down into white dwarfs. But for some white dwarfs, the story doesn't end there. If they're lucky, or unlucky, depending on how you look at it, they might get a second chance at a big finale by becoming a white dwarf supernova. These explosions are rare but incredibly powerful. They spread important elements throughout space and help us understand the universe. From the smallest particles in our bodies to the largest galaxies in the cosmos, white dwarf supernovae have a hand in shaping it all. A white dwarf supernova is the result of a delicate balance between a tiny, dense star and the laws of physics. When a white dwarf collects too much material from a neighboring star, it crosses the point of no return and explodes in a brilliant burst of energy. This explosion not only destroys the white dwarf but also creates and spreads important elements throughout space, helping to build new stars, planets, and even life. The study of these incredible explosions helps scientists measure distances in space, understand the universe's expansion, and learn about the origins of the materials that make up everything around us. So the next time you look up at the night sky, remember that some of the stars you see could end their lives with a dazzling supernova, a reminder of the incredible power of the cosmos.